Hi, welcome back to Educator.com. Today we're going to talk about math, the common issues that I've seen a lot of students have in the math section. Legal disclaimer, test names are the registered trademarks of the respective owners. Said owners are not affiliated with Educator.com. The College Board was not involved in the production of and does not endorse this course. So this lesson is going to go over some of the most common issues students have on the math section. Things that I've seen lots of students of a huge variety of skills, they tend to make mistakes along these lines. So I want to focus on teaching these. First, we're going to discuss some large-scale ideas that can help with a variety of problems. And then we're going to go over some of the really specific fundamental concepts that you really need to have under your belt for taking the SAT. So even if you're strong in math, I'd recommend watching this entire lesson. Something might be painfully obvious, and if you totally understand something and you really don't want to watch it, that's okay. Go ahead and skip on to the next thing. But I really want to make sure you understand everything that's presented here. If you don't understand all of the concepts in this, you're definitely going to miss stuff on the SAT, so it's really important that you get everything in this lesson. If you need any more help with a specific topic, go check out the SAT Math Specific section or browse the rest of Educator.com's math lessons. You got a huge resource here for things that you can learn, so if there's anything you don't quite understand, go out and get it to the point where you do fully understand it. All right, let's get started. Word problems. So many students have trouble with word problems because they don't know how to translate English to math. The hard part isn't doing the math. They're normally good at the mechanics, the algebra, and the arithmetic. It's just getting from English into math speak, right? They're kind of different languages. In fact, they are different languages, but normally people don't think of math as a language, but that's really what it is. So your very first step when doing a word problem is to make variables. You need to create any variables that you might need for the problem. So most often you'll need to define a variable for whatever the problem asks for. If it asks for, how many sheep are going to be on the field, then you need to create some number for sheep. So make it like S, sheep. You might also need to define other variables like values that are talked about but never explicitly given. So figure out what variables you need to set up to do the problem. After you figure out the variables you're going to use, write down what each variable means. I know, you probably think, what's the point of this? I know what the letter means. I've seen so many students make mistakes because they forget what they meant by the letter S. Did it mean the number of sheep, or did it mean like the number of wolves, or something like that? Even things that seem obvious can sometimes be difficult when you're working on a problem. So you want to make sure to write it down so you have this point of reference. Anytime you're not sure what it meant, you look back and you'll have this, oh, right, that's what I'm doing. Writing these things out will help give you a momentum to carry out the whole thing. I'm not kidding about this. I really want you to write down what each variable means. It seems time-consuming and it might seem pointless, but it's not. It's going to be really, really useful. Until you are extraordinarily comfortable with word problems, until you are absolutely ace at math, you should be writing out every single variable that you're using. I still do this when I'm working on complex problems because it's really, really important. Keeping track of what you're doing is like the most important skill in math and a lot of sciences. And if you can't do that, you're not going to be able to get anywhere. And the first step to doing that is writing down what variables mean. Next thing you want to do is you want to make equations. So you have this stable of variables, then you want to figure out what the word problem is telling you about those variables. So the word problem is going to give you information on how the variables relate to each other or other numbers. Use that information to create equations. Make equations out of what the word problem says. Also, you need to make sure your equations represent what the word problem says. This can often be a problem, is people will mistake how to translate that English into math. So if you're not sure if you translate it correctly, just plug in a hypothetical number. And we'll explain that a little bit more when we do an example in just a moment. But plug in a hypothetical number to make sure you've got your equation set up properly. Plug in something and make sure that the English, if you'd plugged it into the English, if that would make the same output as if you'd plugged it into the math equation you just built. If they agree with each other, you're probably good to go. If they disagree, you need to figure out a new equation because it's wrong. Once your equations are all set up and correct, now you're ready to just do some basic math. Now it's just an easy homework problem normally. So solve for whatever the word problem asked for, and you're done. Here's an example. Adam, Brittany, and Charles each have some number of apples. Brittany has twice as many as Adam and 5 more than Charles. Adam has 7 fewer than Charles. How many apples does Charles have? So we might get lost in this if we just try to figure out a number right by looking at it, right? So what we do first is we come up with variables. Obvious, we need to figure out each one of these guys, each one of these the numbers of apples associated with each person. So A is going to be number of apples for Adam. No surprise there. B is going to be the exact same thing, but for Brittany. And C is going to be the exact same thing, but for Charles. No surprise there at all. So now we want to set up what are the equations that come out of this. We've figured out our variables, now we need to set up equations. Brittany has twice as many as Adam. What does that mean? Brittany has, so her number is equal to Adam's number times 2. Let's check and make sure we got that right. This is what I mean by hypothetical number. If Brittany has 10, then if she has 10 is twice as many as Adam's, then if Brittany has 10, Adam must have 5. So if Brittany has 10 here on the B, then 2A, oh yeah, A does have to be 5. Great, that checks out hypothetically. Brittany has 5 more than Charles is what else it says. So Brittany plus 5 equals Charles? No. Brittany equals 5 more than Charles, so Charles plus 5. We check this again. Let's say Brittany has 10 apples. Then if Brittany has 5 more than Charles, then Charles must have 5. So if Charles has 5 here, then Brittany has 5 here. Perfect. Finally, we set up Adam has 7 fewer than Charles, so Adam is going to be Charles, but 7 fewer. So now we've got 3 equations. We're ready to solve things. We'll solve this by substitution. So A equals C minus 7, B equals C plus 5, B equals 2A. What do we want to find out? We want to find out what Charles's number is. So we want to be able to keep C's in our final equation. So let's go, B will go in here. So we've got 2A equals C plus 5. And then we also know here A equals C minus 7, so 2 times C minus 7. Now it's getting a little hard to tell parentheses from Charles's, so I'm going to make the parentheses extra obvious, equals C plus 5. We start working to solve this out. We've got 2C minus 14 equals C plus 5. We move the 14 over to the right side. We move the C to the left by subtracting. We'll get C equals 19. Charles has 19 apples. And if we wanted to, we could go through and check this out. Does this make sense? If Charles has 19 apples, then that would mean that Adam has to have 12 apples. Brittany would have 24 apples. So 24 plus 5, yeah, that's 19. 19 minus 7, yeah, that's 12. Everything works out. Everything still makes sense.